Hi, I am Devi Abhirami, Assistant Professor, Department of Mathematics. Today I am going to take a lecture video on the topic test of hypothesis, small sample test, t-test problems and solution in the subject discrete mathematics with probability and hypothesis testing. My problem is a manufacturer claims that the average lifetime of an LED bulb is 5000 hours. A sample of 10 bulbs gives an average lifetime of 4800 hours. With the sample standard deviation is 300 hours. Using one sample t-test, we can compute the t-test statistics. So in my previous video, I have explained that the t-statistics can be calculated by using a student t formula. Student t formula is nothing but x minus mu by s by root n. X bar means mean of that given data. Mu means population mean. S means standard deviation and n means sample size. Here they have claimed that the mean value is 5000 hours. Sample mean is 4800. Standard deviation is 300 and the sample size is 10. So I am going to calculate this value by substituting in my formula. By substituting I will get 4800 minus 5000 divided by 300 by root n. The 300 by root n is calculated separately because we can calculate the standard error by giving those values. So if I divide it by 94.87, I will get the t value as minus 2.11. So this is the t-test statistics for this LED bulb sum. Here the degrees of freedom is n minus 1. Number of sample size is 10. So 10 minus 1 we get 9. And the second problem is, in a data science project analyzing employee performance, a sample of 16 analysts from a firm yields an average daily output of 42 reports with the standard deviation is 3.8. The standard mean is 40 reports. Conduct one sample t-test at 1% level to assess the firm analyzed exceed the standard deviation or not. For this case, we can formulate the hypothesis. What we have seen in the previous video is there are two types of hypothesis, that is null hypothesis and alternate hypothesis. Null hypothesis means we can accept the right one. Sometimes we can reject it also. If we reject it, then we can accept the alternate hypothesis. So here I am formulating two hypotheses. The mean value that is equal to 40. Suppose it is not equal to 40, then it should be greater than 40. It is a right-tiled test. They have given the data. So I am going to simplify it by using my formula. So if I simplify it, I will get the answer as 2.11. Okay, so 2.11 is less than my table value because my table value is 2.6. So 2.6 is greater when compared to 2.11. So if it is smaller, then we can accept our null hypothesis. We framed our null hypothesis as h naught mu is equal to 40. So I can accept h naught at 1% level of significance. We can conclude that analysts exceed the standard of 40 reports per day. This is how we can conclude the result by using the hypothesis test. And my third problem is, a marketing team tests a new ad campaign by surveying 20 customers, finding an average satisfaction score of 7.8 out of 10. From this, the standard deviation is 1.2, population mean is 7.0 and the alpha value is 5%. Now I am going to simplify it by using a t-test. The given data are sample size is 20, sample mean is 7.8, standard deviation is 1.2, population mean is 7.0 and the alpha is 0.05. Here I am going to frame the hypothesis in the two types, null hypothesis and alternate hypothesis. Null hypothesis is equal to my satisfaction score, whereas the alternate hypothesis should be greater than the satisfaction score. Okay, so now I am going to simplify it by using my t formula. T formula is nothing but t is equal to x bar minus mu divided by s by root n. So if I simplify it, I will get my numerator as 0.8 and my denominator is 0.268. If I divided it, I will get 2.99. I'm going to check whether it is accepted or rejected. While comparing with my table value, it is 1.72, so I can reject my null hypothesis. If the null hypothesis is rejected, then the alternate hypothesis is automatically will be accepted. So the report will be greater than 7. Therefore, we conclude that the new combine has significantly improved the customer satisfaction. Okay, from the previous problem, similarly, the 20th problem is also solved, but it is in the case of two types test. That is, the sample size is 2, 15, 19, and the mean reduction is also a 2 type, 2.80 and 7.40, and the standard deviation is also for the two data 3.10 and 4.20. For this test, in the previous video itself, I have explained the Welch-Stattermine. So Welch-Stattermine is also used here to find the degrees of freedom. So while substituting the known data, I will get the answer as 0.0772. So the degrees of freedom is approximately equal to 31.89 is 32. By comparing it with critical value as plus or minus 2.04. So we can conclude that the blood pressure reduction compared to the placebo. Okay. This is how we can use the hypothesis test to compare any two data whether it has significantly improved or not. Hypothesis testing is a very important testing for testing those analysis. Thank you.